All right. Good morning, Integrated 2. Okay, so first of all, I wanted to point out that I know I haven't got the tests in yet, and that's because I don't have the tests. However, today being Monday, that is when you're watching the video, I will be getting the test this afternoon. So as soon as I get those, I'm just going to grade those the rest of the day. So those should be in tonight, tomorrow at the absolute latest, but I don't see any reason why they won't be in tonight. Because if I have them today, I can get them done today. All right. Um, that said, I heard from Miss Moore and Miss Wiggins that we're going to do more practice on solving by factoring today. So I found a worksheet for that. So let's go ahead and do that. All right, so I'll do a few of each type of problem. And I'll focus a little bit more on the ones that are hard to factor because I know we need to keep practicing those. Those are the tricky ones. All right, so first one I'll do is this first one here. So what you want to notice is that we're solving by factoring, right? So there's your hint. We're going to factor it. So this one, our A, right? We got that invisible 1 there. So we can factor these the easy way. We're just looking for two numbers that are going to multiply to 12. And those same two numbers need to add up to 8. All right, so think about what multiplies to 12, what adds to 8. You're going to get 2 and 6. So what that tells us is that this factors, this whole thing right here, that factors into those two numbers that we just got. It will give us an x plus 2 times x plus 6. And then don't forget that's going to be equal to 0. All right, so remember, notice what we've got now. And remember what we talked about on Friday. If you've got two things that multiply together, right, this thing times this thing, they're multiplying together and they equal 0. Mathematically speaking, that means that we have two options. Either the first one equals 0 or the second one equals 0. All right, so we can split it into two separate equations because we have two possible solutions. Either the first one equals 0 or the second one equals 0. In each of these, we're one step away. So I'll get a negative 2 over here, and then subtracting 6 on both sides here, we will get a negative 6. So those are our two solutions right there. X is negative 2, x is negative 6. All right, let's try another one. So notice that one, what we just did, is very similar to B, D, and F. All right, those four are pretty much the exact same thing. The only thing that we have to be mindful of is on D and F, notice that this is negative. So your original factors are going to be negative numbers, which means that your answers, your actual solutions that you get at the end, are going to end up being positive. All right, so C and E, these two are also similar, but they're in a different way. These two are similar to each other. I'll do E, and then C is very similar to E. All right, so when we've only got two different terms, right, we've got one term right here and another term right here. Both terms contain a variable, right? They both have an x. What we're looking to do is we're going to take out a greatest common factor. All right, so what you've got to notice is that x goes into both of these terms. I can take out an x. So what that means is I'm going to divide each of those terms by x, and I will get the other factor. All right. So x squared divided by x is x, and then 2x divided by x is just 2. So those are going to be our factors right there. You know what? I'll do C as well, just so you can see an extra example of this. All right, so these ones actually end up being pretty easy as well. As long as you get that greatest common factor step, these ones are easy as well. So we're going to set that equal to 0, right? And then this one could also equal 0. Whoops, x minus 2. And then this one's already solved. We don't have to do anything here. And this one, we are one step away, and we will get x equals 2. Okay. Let's see what else. I just want to take a look and see if there's any more of these. There's actually not any more of these, and I don't want to do all of the ones of the same type. So it's that similar idea for C, except we're not factoring out an x because x's aren't in there. We're going to factor out another letter. Okay. So go ahead and try the rest of these under problem number 1, and then I will go to problem 2. Do some more examples down here. All right. So same type of idea, except this time A is not 1, so we've got to do the diamond in the box method. All right, remember the first thing we do with these problems, we're looking to factor them, right? So what we're going to do is we're going to make our diamond here. And then if you remember, up top goes B, so it's going to be a 28 up top. And then down at the bottom, it is A times C, 3 times 9, 27. So what that tells us is we're looking for two numbers. We want to multiply to 27 and add to 28. All right, so think about everything that multiplies to 27. I can only think of two things, right? Either 3 times 9, and that doesn't work because 3 plus 9 is not 28, or 27 times 1, and that works because those add to 28. So we're going to go with 1 and the 27. All right, so those are the two numbers we find. All right, so now we can do the box and find the actual factors. So if you remember top left of the box, that is the first term, 3x squared. The bottom, this bottom right corner of the box, that is going to be your C. It is 9. And then the other two, we just used the those two numbers that we just found, the 1 and the 27. So we got like a 1x, and then we got a 27x. And then we're going to go row by row, column by column, take out those greatest common factors. All right, so looking at our top, or actually no, we usually go columns first. So we'll go left column right here. Largest number that goes into both 3 and 27 is going to be 3. And then when you have an x squared and x, you can always take out an x. And then on our right column, not much we can do, but largest number that goes into 1 and 9 is just 1. And we can't take an x out because the 9 does not have an x. And then we'll look at our rows. So top row, between 1 and 3, again, that's just a 1. But I can take out an x because both of these do have an x. And then down below, we're looking at a 27 and we're looking at a 9. The largest number that goes into 9 and 27, it's going to be a 9. All right, so those are our factors, 3x plus 1 and x plus 9. But remember, we're not done yet because we are actually solving for x now, right? Notice it's not just an expression, it is an equation because it has equals 0. So this whole thing is still equal to 0. And again, we're going to do that same thing. So if we have two things multiplied together that equal 0, either one of them equals 0 or the other equals 0. All right, so we're going to split them into two separate equations and solve them. All right, so whenever we've got our two-step equations, remember, do your addition and subtraction first. Don't try to divide by 3 yet. Just subtract the 1 over first. Now, it's not necessarily wrong to do division first. The challenge that comes with that is a lot of times you're going to create a bunch of fractions in the problem. So if you don't want to deal with fractions, just do the addition and subtraction first. That way, the only time fractions will show up will be in the actual answer. So that way, you're not having to actually do any addition, multiplication, anything with the fractions until you get to that answer. All right, so we'll do our subtraction first. Subtract 1 on both sides. We'll get 3x equals negative 1. And then our last step is we divide by 3. And we get x equals negative 1 over 3. And then over here, we can subtract 9 on both sides and get x equals negative 9. All right, so notice, this, regardless of whether a equals 1, right, if that's a 1 or not, our steps are the same. We're still going to factor. We're going to split it off into two equations and solve each of them for x. The difference, the hard part about these is that the factoring step itself is an extra challenge because we have to do the diamond in the box method. All right, board number 2 here. First thing I see is I see a couple new types of problems. In fact, I see this one right here. I see this one right here. And actually, no, that's it. Okay, so here's what we're going to want to do with these types of problems. Is what I would do is we've only got 2 terms, right? But notice, in what we had done before, both terms contained a letter, right? This guy's got an M, this guy's got an M. This guy's got an X, this one has an X. But here, only one term has a letter, right? We've got a b here, and then that's just a number. An x here, and then that's just a number. All right, so here's what I would do for those. I would get the number over to the other side. All right, so I'll do d. So I'm going to get the number over to the other side. So I'm going to add the 1 on both sides. So I get 16b squared equals 1. And then I'm going to divide by the constant. So I'm going to divide by whatever is being multiplied by our letter. So 16 divided by 16 makes a 1. So I get b squared equals 1 over 16. And then what's going to happen once we do those two steps? That letter that we want is still going to be squared, right? I still got a b squared. So you're going to take the square root, right? That is the opposite of squaring a number. We're going to take the square root of both sides. So that cancels out the squared. The square root of a number squared is just the number. So that cancels out, and we've just got a b now. The square root of 1/16. All right. I don't know if we learned this property of square roots yet, but whenever you've got a square root of a fraction, what we can do is we can look at the square root of the top over the square root of the bottom. All right, so when I say the square root of 1, it means what number times itself equals 1. Well, that's just 1, right? Because 1 times 1 is 1. So it'll be a 1 up top. And then on the bottom, I'm going to rewrite this a little nicer. On the bottom, we're saying what number times itself equals 16. That's going to be 4, right? It's 4 times 4. And then whenever we've got square roots, it's a plus or minus. So it is plus 1/4 or minus 1/4. Those are going to be our two solutions. All right. And C is going to be very similar. You're going to add that 36 to both sides, and then we're going to want to divide this 4 over, and then we're going to take a square root. And don't forget your plus or minus. All right. So those are the general steps to doing C, but it's the same thing as what we just did here. Or just with different numbers this time. Okay, let's see what else we've got. We just got a few more where it's the same idea of we're looking at some more factoring with a not equal to 1, right? Because notice that here our a is 1, a is 1. So those ones I think hopefully so you're starting to get the hang of. I'm going to go ahead and do F just so you have another example of factoring when a is not equal to 1. All right, so here we go. So let's see what we got. First thing, we're going to do our box, or our diamond, I mean. And up top goes B. So that's our negative 12. Down below, it is A times C. 4 times 9 is 36. So we got us looking for two numbers. We're multiplying to 36. And we are adding to negative 12. All right, so if we're multiplying to a positive and adding to a negative, the only way to do that is with two negative numbers, right? Because a negative times a negative, that will work here. It multiplies to a positive, and a negative plus a negative will work here because that adds up to a negative. All right, so think about what multiplies to 36, adds to negative 12. It'll be negative 6 and negative 6. All right, so we can take that, put that into our box. We've got our box method set up here. Top left corner is always the first term, so 4x squared. Bottom right is C, that is 9. And then those two that we just found, the negative 6 and negative 6, will go in the other two positions. All right, again, column by column, row by row. Take out the greatest common factors. So our left column here, the largest number that goes into 4 and 6 is going to be 2. And then x squared and x, we can take out an x. And then notice, though, this is the special case, right? Because C is positive, but B is negative. So what you got to remember for there, again, this is something you can put in your notes. When C is positive and B is negative, you can write this down. It'll be helpful for the test. These two numbers that come out, actually I'll do them in a different color. The numbers in the orange positions, you need to make them negative. These two are going to be negative, these two greatest common factors. All right, so that said, with that in mind, when we're looking at negative 6x and 9, we are in the right column right here. We are going to be taking out not a 3, but a negative 3. And that is because the C was positive and B was negative, back up here in our original equation, right? C is positive, B is negative. All right. I'm going to erase up here just so we can see the original equation. I got too much going on now. All right. And then let's look at row by row. So our top row, 4x squared and negative 6x. Again, that's actually the same thing. We already looked at that. It's 2x. And then once again, negative 6x and 9. It would be 3, but because of that positive C and negative B, we want a negative 3. We are making those both negative. All right. So those are our factors. Don't forget to set them equal to 0. So we got 2x minus 3 times 2x minus 3 equals 0. All right, and again, each of those we can set equal to 0. But notice those are the same thing, so we really only need to solve it once. We don't need to solve it twice. All right, so I can add 3 to both sides. I'll get 2x equals 3, and then we'll divide by 2. X equals 3 halves. And notice that satisfies both of them because they were the same equation to begin with. And that's okay. Occasionally you're only going to get one answer, not two. The only times that you're going to see that for these types of quadratic equations is when we have both of the factors are the same, also known as a perfect square. All right, that's it. Most of these or all of these are similar to what we have done at this point now. We've seen one of all the different types that you're going to see on the worksheet. Please let me know if you have any questions. As far as grades, again, that will be posted today. And as far as retakes and all of that go, you are always welcome to do retakes. Retakes are open notes. Just coordinate with Miss Moore so that way she can have an extra test ready to go. If you want it graded immediately, have her send pictures of it to me, and I will grade it immediately. Otherwise, I will grade it whenever I get the next batch of tests, which will probably be tests and work, which will probably be in another week. All right. Let me know if you have any questions.